So in this lecture, we are going to cover circles on an Argand plane. So first of all, we will learn what is the general equation of a circle on an Argand plane. So to know the general equation of a circle on an Argand plane, let us just recall the general equation of a circle on a Cartesian plane. We know that the general equation of a circle on a Cartesian plane is x square plus y square plus 2gx plus 2fy plus c equals to 0, whose center is at minus g minus f and radius under root g square plus f square minus c. Is it clear? So this is exactly what we have learned in Cartesian system. Okay. Now, what is x and y? X and y is basically the variable point on the circumference of this circle. So in an Argand plane, let us denote this variable point by z, which is nothing but x plus iota y. Is it clear? So z bar will be what? X minus iota y. So now, if I replace the values of x and y from these two, we are going to have x square plus y square can be written as z bar plus 2g. What is x? X is nothing but z plus z bar by 2 and y is nothing but z minus z bar by 2 iota. Correct? So let me replace it. Is it fine? So we can write this thing as z bar plus, okay, let me just multiply numerator and denominator with iota. So the denominator will be iota square, which gives you minus 1. So it will be minus f z minus z bar plus c equals to 0. Is it clear? Now, let me just do a little simplification. I'm sorry, iota will be there. So I can write this thing as g minus f iota z plus g plus f iota z bar plus c equals to 0. Is it clear? Let me denote alpha by g plus iota f. Therefore, alpha bar will be g minus iota f, correct? Therefore, the equation becomes z bar plus alpha bar z plus alpha z bar plus c equals to 0. And this is the general equation of a circle on an Argand plane. Look it very carefully. It is very easy to remember. We know that the equation of a straight line is something like this. This part represents actually in the complex plane the general equation of a straight line. So along with that, you have just added z bar. So that gives you the general equation of a circle on a complex plane. It's easy to remember. No problem. Okay. Now two things will arise here. What will be its center and its radius? Okay, let us walk on it. The center of this circle, the general equation of a circle in the Cartesian plane is minus g minus f. So minus g minus f is basically nothing but minus alpha over here, because minus alpha is what? Minus g minus iota f. Okay, therefore the center will be nothing but minus alpha. Is it clear? And what about its radius? Its radius is under root g square plus f square minus c. So in this case, the radius will be under root mod of alpha square minus c. It's all same because your alpha is g plus iota f, alpha bar is g minus iota f. Therefore, alpha bar is nothing but g square plus f square, which is same as your mod alpha square. Therefore, the general equation of the circle is z bar plus alpha bar z plus alpha z bar plus c equals to 0. Its center is at minus alpha and its radius is under root mod alpha square minus c. Can you remember this much? One thing you must remember over here, that this will represent a circle on a complex plane when these two signs are equal. That is, if there is a plus sign, in both the cases it will be plus. If it is minus, then in both the cases it will be minus. Be very careful. Otherwise, that will not represent a circle on an Argand plane. It's a very, very important point to be noted. If I ask you z bar minus alpha bar z plus alpha z bar plus c equals to 0, does it represent a circle? No, it does not represent a circle. Is it clear? Let us take an example. Now, my question is, does it represent a circle on an Argand plane? Number one. Number two, if so, what is its radius and its center? First of all, we have to see that this is of the form, if I write this thing as my alpha, then this is nothing but my alpha bar z, and a constant term is there. So this very much resembles to the equation of the general equation of a circle on an Argand plane. Hence this represents a circle. You see, these two signs are same again. So it represents a circle, number one. Number two, to find out its center and radius, first of all you must remember, you must make the coefficient of z bar 1. That's exactly what we have learned in our Cartesian system also. We used to make this x square plus y square coefficient 1 every time. Okay. So, in this case, there is a 2. So what I will do here is, first I will divide both sides by 2. So what we are going to have? Is it clear? So, in this equation, the center will be, what was the center? Minus alpha. What is that? Alpha is basically the coefficient of z bar. So in this case, the coefficient of z bar is alpha by 2. Therefore, its center will be at minus alpha by 2. Am I correct? And its radius will be under root alpha square minus c. So in this case, what will happen? It will be under root mod of alpha by 2 square minus c, means minus of 9 by 2. Am I correct? So that gives us under root 1 by 4. Here alpha is basically 4 plus iota. So alpha bar is 4 minus iota, and therefore your alpha square will become alpha into alpha bar, which gives us 4 plus iota into 4 minus iota, that gives us 16 plus 1, that is 17, correct? So in this case it will be 17 plus 9 by 2, okay? So what we are having, a little calculation, it is 17 by 4 plus 9 by 2, that gives us half under root 35. Is it clear or not? So this is the radius and this is the center of that circle. Of which circle? Of this circle. So two things you must remember here. That is, whenever we are calculating the center and the radius of any circle, first thing that you must remember is that first you check whether these two signs are same or not. If they are not, no need to find out its center or radius because it will not represent a circle. And number two, the thing is that after inspecting this thing, you see coefficient of z bar must be 1. If it is not there, forcefully you make it 1. And then you find out your center and radius accordingly. Is it fine with you? Absolutely? Okay. Now let us find out diametric form of a circle. What is the diametric form? That is, suppose we have been given the extremities of a diameter. Suppose this point is Z1 and this point is Z2. Now we have to find out the equation of this circle. What is Z1 and Z2? These are the extremities of this diameter, let us say AB. Right? Let us choose any point on the circle, which is an arbitrary point. Let us denote it by Z. Okay? Now, what is the slope of BC? What is the slope of BC? That is the complex slope we are talking about. When we know 2 points, the slope will be, the complex slope will be Z minus Z2 divided by Z bar minus Z2 bar. This is the slope of BC. And what is the slope of AC? It is Z minus Z1 by Z bar minus Z1 bar, correct? Now, as we all know that the angle in a semicircle is always a right angle, that is, this angle is 90 degree. And we know that the sum of the complex slopes, will be equals to 0 when two lines are perpendicular to each other. Therefore, the equation of the circle becomes Z minus Z1, Z bar minus Z2 bar plus Z minus Z2 into Z bar minus Z1 bar, which is equals to 0. And that is exactly what is the equation of the circle when the extremities of the diameter of any one diameter are given like Z1 and Z2. The equation will be this. Is it clear? Is the diametric form of circle is clear to you? Absolutely? Okay. Now one more thing I can say here, that if suppose I have taken, say, two circles, I'm sorry, this is beta, Z bar plus C2 equals to 0. These are the two equations, circle on a complex plane. Now these two circles, this circle, the first one is having its center as at minus alpha and radius as mod of alpha square minus C1, and the second circle, it has its center as minus beta and radius mod of beta square minus C2. Is it clear? Now, my question is, what is the equation of its radical axis? Radical axis. Now, those who have not done coordinate geometry, you will not understand what is radical axis. But I will suggest you to please see your coordinate geometry part to understand what is radical axis, because this is not the right place to discuss about the definition of radical axis and detailing about it. Okay. So, I just want to recall this thing, that when two circles are used to given, suppose S1 is 0 and S2 equals to 0, we used to find out the equation of the radical axis just by subtracting one circle from the other. Okay, so when these two expressions are subtracted, we always used to get the equation of the radical axis. Same thing here. To find out the equation of the radical axis, all I will do is I will simply subtract these two equations to get and that will be the equation of the radical axis. Is it clear or not? Absolutely. So have you understood how to find out the radical axis of when two equation of two circles are given? We all know that when two circles intersect each other, the radical axis become its common chord. The radical axis become its common chord. So this can also be treated as the equation of the common chord of these two given circles. The only condition is that they are intersecting each other at two distinct points. Is it clear? Now, when these two circles touch each other, whether externally or internally, then in that case, the radical axis becomes the tangent to this circle at this common point. This point is what called your common point for both these circles. At this point, the radical axis will be the tangent. Is it clear? So this equation can also be treated as an equation of a tangent when two circles touch each other externally or internally. Is it clear? Okay. Now, let me give you, suppose the two extremities of a diameter is given to you as 2 plus iota and minus 2 plus iota, and the question is to find out the equation of the circle. Now, one thing you see here, that the diametric form of the circle is given by this equation, where its center will be at z1 plus z2 by 2. This is the center because the midpoint of these two extremities will be the center of that circle. And what is the radius of that circle? It's simple. You will find out the distance between z1 and z2. Is it clear? And then you divide it by 2. So that gives you the radius of that circle. Is it clear? So now, when the extremities of the diameter is given and it is required to find out the equation of the circle, what I will do, I will take one point to be z1 and another point to be, say, z2. Therefore, the equation of the circle will be z minus z1 into z bar minus z2 bar plus z minus z2 into z bar minus z1 bar, which is 2 minus iota, that is equals to 0. Is it clear? So let us just open the brackets. So here we are getting z bar, which is nothing but your z bar from here, which you can write as mod z square also. So we are getting z bar from here, we are getting z bar from here also. So it will be 2 times z bar I'm not going for its calculation and all that you can do by yourself, but the main thing here is that this is the equation of that required circle. This is number one. And number two, if I ask you, what is the center of this circle and its radius? So what I will do is, the center will be nothing but z1 plus z2 by 2, which is your basically coming to iota by 2. Is it clear? That is, the point on the complex plane will be 0, half. Okay? And what will be its radius? The radius will be mod of z1 minus z2. That gives us 2 plus iota minus of minus 2 plus iota. If I open the bracket, we are going to have mod 4, which is 4. So this is the length of the diameter. So what is the length of its radius? It will be 4 by 2, that is 2 units. Is it clear to all of you? Absolutely? Okay. Now suppose two circles are given on the complex plane. One is, and another one is. Okay. For the first circle, the center will be at minus alpha. Radius will be under root mod of alpha square minus c1. And for the second one, it will be minus beta under root mod beta square minus c2. Okay. Let me just denote this thing radius as R1 and this is my R2. There are two circles. What are the possibilities? Tell me. The two circles can be like this, where these two circles will not intersect each other. It can be also like this, that two circles are touching each other at only one point externally. Or else it can be touching the circle at only one point but touching internally. Okay? Or the last one can be one circle is inside the other circle. Yes? These are the four options that you can say about these two circles. Okay? The relative position of those two circles. Now, in this case, look at carefully. One center is minus alpha and other one is minus beta. Therefore, the distance between the center is mod of alpha minus beta. Yes or no? What is alpha minus beta? This is the distance between the two centers. Let me denote this thing by, let us say AB. Okay, this is A, this is B. Okay. Now, when this condition will fulfill, that is, these two circles will not intersect each other. When you will find that your AB is greater than R1 plus R2, that is, the distance between their centers is greater than the sum of their radii. Yes or no? The sum of their radii, if the sum of the radius is less than the distance between AB, then you will say that these two circles are not intersecting each other. As simple as that. In this case, observe carefully that your AB, that is the distance between the centers, will be equals to the sum of their radii. Yeah. In this case, what will happen? In this case, this is my A, this is my B. Then what you will write? That your AB is nothing but R1 minus R2. Yes or no? When R1 minus R2 equals to AB, then you will say that these two circles intersect each other at only one point internally. Now, in this case, what I will say is basically, this is say A and this is say B. You will write that AB is less than mod of R1 minus R2. Why I have taken mod? Because I don't know which one is, though we have considered that this radius is R1 and this radius is R2. It may so happen that you can take the reverse one. In that case also, we are only calculating the positive value of their difference in their radii. Okay, the positive value of the difference of their radii. Now, if you find that AB is less than mod of R1 minus R2, then we will say that one circle is inside the other circle. Is this conception clear or not? Tell me very fast. Have you understood this? This all you people have covered in coordinate geometry in Cartesian plane. And one more thing I have not discussed here. I'm so sorry. It may so happen that two circles intersect each other at two distinct points. This case I have not considered here. Okay. So, what will happen in that case? Tell me fast. This is my AB. In that case, what will happen? Your AB, see, this is your R1 and this is your R2. This is your R1 and this is your R2. So from this triangle, what you can say? We know that the sum of two sides is always greater than the third side. So here we will say that AB is less than R1 plus R2. Tell me yes or no. Tell me yes or no. So when AB is less than R1 plus R2, then we will say that these two circles intersect each other at two distinct points. Is it clear? Fine. So these are the 5 cases that we must remember. Let me take the same thing where these two circles are, let us say, intersecting each other at two distinct points. That is, the distance between their centers is less than the sum of their radii. Okay? So, let me join this. This is my A, which is your minus alpha. This is your B, which is your minus beta. This is your R1 and this is your R2. Let me join this. Now, I am eager to find out the angle between these two radius. This is also called the angle between these two circles. Okay? This angle can be said as the angle between these two circles. How to find it out? Look it carefully. Let us say this angle is theta. We know that cos theta is nothing but R1 square plus R2 square minus AB square divided by 2 times R1 into R2. Tell me yes or no. This is your nothing but cosine rule. This is your cosine rule. So, in this case, your cos theta is nothing but R1 square plus R2 square minus AB square. Okay. So, what you can write here? The radii is root over alpha square minus C1 and R2 is root over beta square minus C2 and their center is at minus alpha and minus beta. So, we can write here mod of alpha square minus C1 plus mod of beta square minus C2 minus AB square is alpha minus beta whole square divided by 2 times R1 into R2, that is under root mod alpha square minus C1 root over mod beta square minus C2. Yes or no? Yes or no? Now let me just open the numerator thing. So we are getting alpha square minus C1 plus beta square minus C2 minus, if I open this one, this is basically alpha minus beta into alpha bar minus beta bar. So there we will get mod of alpha square plus mod of beta square minus alpha beta bar minus alpha bar beta. I'm not showing this calculation because I have shown this a lot of time. So the denominator, let us keep it as it is. Now, in the numerator, what we are getting, if we open the brackets, this alpha square, beta square goes off. So we are left with alpha beta bar plus alpha bar beta minus C1 minus C2 divided by 2 times mod of alpha square minus C1 root over mod of beta square minus C2. Correct? Now suppose if these two circles intersect each other at 90 degree, that is, the angle is 90 degree. Then we say that these two circles intersect each other orthogonally. Yes or no? When two circles intersect each other orthogonally, we say that the angle between them is 90 degrees. So cos 90 degree, we know it is 0. That is, this numerator part will be equals to 0. Therefore, we can write that C1 plus C2 will be nothing but alpha beta bar plus alpha bar beta. And that is the condition when two circles, the equation of the circles are ZZ1 plus alpha bar Z plus alpha Z bar plus C1 is 0. ZZ bar plus beta bar Z plus beta Z plus C2 equals to 0. These two circles will intersect each other orthogonally when C1 plus C2 is nothing but alpha beta bar plus alpha bar beta. Okay? This is the one way of remembering this. When the two circles intersect each other orthogonally. And the most important thing which you can remember, which you have to remember rather, that is the sum of the squares of the radii will be equals to the square of the distance between their centers when the curves intersect each other orthogonally, because this part will become 0. Am I correct? So R1 square plus R2 square will be equals to AB square when these two circles intersect each other orthogonally. Is it clear or not? Absolutely. So we have to remember this as well as this. Okay? See this question. Find all circles which are orthogonal to mod z equals to 1 and mod of z minus 1 equals to 4. So we have to find out all the circles which are orthogonal to these two circles. Okay. Now, let us say this is my circle, which is your mod z equals to 1. And there is another circle. Say this circle is mod of z minus 1 is 4. Now we are going to find out the circles which are orthogonal to both this and this. Okay? Let me say the equation of this circle be z minus z1 equals to r, where z1 is the center of the circle and r is the radius of this circle. Okay? Let us say z1 is nothing but a plus iota b. That is, the coordinate of this point is a comma b, in other words. Okay. Now, since, one more thing let me just tell you, that the center is 0, 0 and the radius is 1 for this, and the center for this circle is 1, 0 and radius is 4 units. This is 4 units, this is 1 unit. Fine. Now, this circle and this circle, they are orthogonal to each other. So we can write the distance between their centers will be equals to the square of the distance between the centers will be equal to the sum of their radii. That is, sum of the squares of their radii, I should say. So r square plus 1 square is nothing but a square plus b square in this case. Okay? The distance between these two centers is under root a square plus b square. So that's exactly what I have written, which is equals to the sum of the squares of their radii. The radius of this circle is r and for this circle is 1. So it is r square plus 1 square. Same thing with this circle. The distance between their centers here is nothing but a minus 1 whole square plus b square. And the sum of the squares of the radii is r square plus 4 square. Tell me yes or no. Okay. Now let me subtract this two. What we are going to have? B square goes off. So here we are getting 1 minus 16 equals to a square minus a square plus 2a minus 1. So that gives us what? Minus 15 equals to twice a minus 1. That implies 2a equals to minus 14 implies a is nothing but minus 7. Is it clear? A is nothing but minus 7. Now, what is the radius of this circle? We can get it from this equation, where we know that r square is nothing but a square plus b square minus 1. Now, a is minus 7, so this thing will give you 49 plus b square minus 1, that is 48 plus b square, right? So, r is nothing but under root 48 plus b square. Okay? R cannot be negative, so I am rejecting the minus sign. So we got that a is minus 7 and r is under root 48 plus b square. So what is its center? Center of the required circles are minus 7 comma b. Minus 7 comma b is the center for this kind of circles which are orthogonal to both of the circles. Now, as b varies, you are going to get different kinds of circle. Are you getting my point? Here b is not fixed. B belongs to any real value. So for any b, you are going to get different centers. At the same time, the radius will get changed. As b changes, the radius changes. So we are going to have different circles which are orthogonal to both these circles. Therefore, the required equation of those circles are mod of z minus, this point is a plus iota b, which is equals to the radius r. So which is nothing but your mod of z minus minus 7 plus iota b equals to r, which is nothing but under root 48 plus b square. So this is the system of those circles which are orthogonal to these two given circles. Is this problem clear to all of you? Okay. Now we will learn different forms of circle. That is different form of representing a circle. What we know, number one, that we have already discussed in previous videos, that if z minus z1 equals to r, this represents a circle whose center is at z1 and radius r. This we know. The second equation of a circle that we have learned in this lecture is the general equation of a circle on a complex plane, which is z bar plus alpha bar z plus alpha z bar plus c equals to 0, whose center is at minus alpha and radius under root alpha square minus c. We have learned this. The third one, which is called the diametric form, that also we have learned. That is, if we know the extremities of the diameter of any circle, let us say the extremities of the diameter be z1 and z2 of any circle, then the equation of that circle will be z minus z1 z bar minus z2 bar plus z minus z2 into z bar minus z1 bar equals to 0, correct? And the radius will be, first the center will be z1 plus z2 by 2, and radius will be the distance between z1 and z2, that is the diameter, divided by 2, which will give you the radius of the circle. Okay? Now let us learn. If an equation is given something like this, z minus z1 by z minus z2 equals to k, let us try to find out the locus of point z on an Argand plane. Now we have to find out the locus of mod of z minus z1 by z minus z2 equals to k. z1 and z2 are the two fixed points. Let us draw it on the Argand plane, say A and B associated with the complex numbers z1 and z2, and z is a moving point moving in a plane in such a way that modulus of z minus z1 and z minus z2 equals to k. Okay, here k has to be greater than 0, right? Because k here is the ratio of two distances, therefore k is greater than 0. Let me join AB. Okay, now if k is 1, then we have mod of z minus z1 equals to mod of z minus z2. And as we all know, I have already discussed in my Locus lecture. Those who have not seen it, link has been given in the description box, so you can check it. So when mod of z minus z1 equals to mod of z minus z2, then z lies on the perpendicular bisector of the line joining z1 and z2, correct? This is one case when k is equals to 1. But if k is not equals to 1, then we have two options. One is either k is lying between 0 and 1, or k is greater than 1. Okay? Now, when k is lying between 0 and 1, observe it carefully. If k lies between 0 and 1, means it's a fraction. Therefore, your mod of z minus z1 will be less than mod of z minus z2. That's exactly what is shown here. Now, you tell me, where does this z lies on this complex plane such that the distance from z1 will be less than the distance from z2? Naturally, the variable point z has to lie somewhere in the left hand side of this perpendicular bisector. Tell me yes or no. Because if it is anywhere in the left hand side of this perpendicular bisector, then the distance AC will be less than the distance BC. That's for sure. Is it clear? Therefore, when k is lying between 0 and 1, the variable point z is lying somewhere in the left hand side of the perpendicular bisector of the line joining z1 and z. Now let us draw the internal angle bisector of angle ACB, which is meeting AB at say D associated with the complex number, say Z3. Okay. Let us now produce BC to E and the external angle that is formed, that is angle ECA. Let us draw the external angle bisector which is meeting the produced line BA at, say, F associated with the complex number Z4. Now we all know that the internal and external bisector of an angle of a triangle are always perpendicular. Therefore, this angle is 90 degree. Is it clear? This angle is 90 degree. That is, angle FCD is 90 degree. So, if we draw a circle by taking FD as the extremities of the diameter, then the circle will pass through FD as well as C. Yes or no? Therefore, the complex number C, that is associated with the complex number Z, I should say. So the complex number Z is lying somewhere on the circumference of this circle. Therefore, the locus of Z is nothing but a circle. When K is lying between 0 and 1. Is it clear or not? Absolutely. Now the question comes, what will be the center of this circle and what will be its radius? Okay. Now you see, clearly the center of this circle will be nothing but Z4 plus Z3 divided by 2, and its radius will be mod of Z3 minus Z4 divided by 2. Tell me yes or no, because mod of Z3 minus Z4 will give you the diameter and the radius will be half of it. Okay. Now the main question comes, what will be your Z3 and Z4? It's a very important thing. If we can find out the coordinate of Z3 and Z4, then we can easily find out these things, that is the center and the radius. But before starting that, let me tell you one thing, that in this case, we observe that point A is inside this circle and point B is outside this circle. Observe this thing carefully. When K is lying between 0 and 1, A that is associated with the complex number Z1 is inside the circle and Z2 is outside the circle. Remember this one. Now let us come for finding out the complex numbers Z3 and Z4. Again, I have done this one in my complex geometry part 1 lecture where I have discussed about the section formula. Let us say this point, I'm not going to discuss it in detail. I will simply give you a bit summary of this section formula. If this point A is associated with the complex number, say Z1 and B with Z2, then if M is a point which divides this line in the ratio K is to 1, that is MA by MB, if it is K by 1, then we say that M will be nothing but Z1 minus KZ2 divided by 1 minus K. If M is externally dividing, the complex number that is associated with the point M will be Z1 minus KZ2 by 1 minus K. And if this point is dividing the line joining AB internally somewhere, suppose M is here, in that case the complex number associated with M will be Z1 plus KZ2 divided by 1 plus K. That is, K has to be replaced by minus K when the point is internally dividing. And if it is externally dividing, then K is as it is in this formula where it will be negative. Now, one more thing I must discuss here. We all know that the internal bisector of an angle of a triangle always divides the opposite side internally in the ratio of the sides containing the angle. That is, I must say that AD by, look it carefully, AD by DB will be nothing but CA by CB, which is mod of Z minus Z1 by mod of Z minus Z2, which is nothing but your K. Yes or no? Therefore, D is a point which is dividing the line joining Z1 and Z2 internally in the ratio k is to 1. Therefore, the complex number Z3 will be nothing but, since it is internally division, therefore it will be Z1 plus k times Z2 divided by 1 plus k. Just now I have explained here this one. The complex number which is associated with Z3 is basically, that is the point D, is this. Is it clear? And we also know that the external bisector of an angle of a triangle divides the opposite side externally in the ratio of the sides containing the angle. It means that the external bisector CF will divide the line joining AB in the ratio k is to 1 externally, like FA by FB will be equals to CA by CB, which is again equals to mod of Z minus Z1 by mod of Z minus Z2, which is equals to K by 1. Okay, so this point F is dividing the line joining AB externally in the ratio k is to 1. Therefore, the coordinate of F, or the complex number which is associated with F, Z4, will be nothing but Z1 minus KZ2 divided by 1 minus K. Is it clear? The moment you have Z3 and Z4 in your hand, so you can easily find out its center as well as its radius. Yes or no? Clear? But overall what we have learned is that when K is lying between 0 and 1, it represents a circle. Which one? The locus of Z. Okay, same thing will happen in the right hand side of this perpendicular bisector if k is greater than 1. The only difference in that will be the point Z2 will be inside the circle in that case when k is greater than 1, and point Z1 will be outside the circle. Otherwise everything remains same. Therefore, what we have learned, that mod of Z minus Z1 by Z minus Z2, if it is k and k is not equals to 1, then Z always lies on the circumference of a circle. Is it clear? And you know how to find out its center and radius. Okay. Now the circle we have discussed right now is basically called Apollonius Circle. The circle that we have discussed right now is what called your Apollonius Circle. Okay. Number 5. If Z minus Z1 square plus mod of Z minus Z2 square equals to K square, if this represents a circle, then what is the condition? This is my question right now. Mod of Z minus Z1 square plus mod of Z minus Z2 square equals to K square. This represents a circle on an Argand plane, depending on a condition. And we will deduce that condition right now. Is it okay? Chalo, let's start. Z minus Z1 into Z bar minus Z1 bar plus Z minus Z2 into Z bar minus Z2 bar equals to K square, right? Because we know that mod Z square is nothing but Z bar. Now if I multiply, we are going to have, let me do it little fast. So we are having Z bar and Z bar is here. So it is nothing but 2Z bar minus Z1 plus Z2 into Z bar. This one goes off. Minus Z1 bar, this one and this one. So we are left with here plus Z1 into Z1 bar is mod Z1 square. Z2 into Z2 bar is mod Z2 square minus K square equals to 0. Is it clear? Now if I divide with 2, so we are having z bar. Now this will represent equation of a circle if its radius, because it represents a circle, you see, because the sign over here are same, and if I treat this thing as my alpha, then this thing becomes my alpha bar, so everything matches. The only thing is that if its radius, what is its radius? Radius is under root mod alpha square minus the constant term. If this radius is defined, radius will be defined only when mod of alpha square minus c is greater than or equals to 0. Why I'm writing 0? Because it may so happen that the circle is a point circle. So that case has to be considered here. But the radius is defined only when the thing which is under the root sign has to be defined. So for that it must be greater than or equals to 0. So that is the only condition that we have to say that this equation represents a circle. Okay, so now we have to work on this. So mod of alpha square means z1 plus z2 by 2, because this is your alpha, mod of this square minus c. C is the constant term, which is nothing but this one here. If this one is defined, then it will represent a circle, and it will be defined when it is greater than equals to 0. So if I open this one, we are going to have minus, if I take LCM 4, so 2 will go here, it will become 2 mod of z1 square, which is greater than equals to 0. Okay, so we are having what? 2k square is greater than equals to mod of z1 square plus mod of z2 square minus z1 bar z2 minus z1 z2 bar. So from here we can write, this can be written as mod of z1 minus z2 whole square. Is it clear? I'm not going to explain you why it is so, because I hope you have understood why I have written mod of z minus z2 whole square is this expression. So from here we can write that k square is greater than equals to half mod of z1 minus z2 whole square, and that is the condition. If exist, then you will say that this equation is going to represent a circle. And we have to remember this, because objective questions used to come from this part. So be very careful about it. Is it okay? Now in this one, in many of the textbooks, they have taken this thing as k. Okay, so it doesn't matter whether you take it k or k square, because in the whole calculation you will find that this k square is untouched. Okay, so it doesn't matter whether it is k or k square. I have taken it k square. So we got that k square is greater than equals to half of mod z1 minus z2 whole square. That is the condition. But if it is k, then also there is no problem. In that case, your k will be greater than equals to half of mod of z1 minus z2 whole square. It's all same. It's clear? So let us discuss the last part of this lecture, which is your circular arc. This I have already discussed in my Locus video. So those who have not seen, the link has been given in the description, so you can check it. Suppose if I say that arc of z minus z2 by z minus z1 equals to alpha. What do you mean by that? Z minus Z2 is basically a ray emanating from a point Z2 and moving along this vector. Let us say Z is this point. Okay? This is my Z2. And Z minus Z1 is basically a ray emanating from the point Z1 and moving along this ray, and both of these vectors are converging to a point Z. And we have considered this angle to be alpha. Okay? You see, in the locus, I have discussed everywhere that point always, whenever we have considered two vectors and we found the angle between them, every time we have considered that it is, both of the vectors are co-initial vectors. That is, they are emerging from a common point. But in this case, the thing has been reversed. I mean, these two vectors are not initiating from a point, rather than these two vectors are converging to a point. Is it clear? It is not diverging from a point, but it is converging towards a single point. Now, in both these cases, this is actually, it has been discussed in vector algebra. Those who have done vectors properly, they know that in this case, whenever we are finding out the angle, whether the two vectors are converging to a point or diverging from a point, the angle remains same. This I will discuss in details in our vector algebra lectures. But here you remember, if two vectors converges to a point or it diverges from a point, the angle doesn't make any changes. Okay? So in this case, your Z is moving in such a way from these 2 points such that this angle is alpha. Now look it carefully. If I join this one, Z1 and Z2, and if this is the arc of a circle, then if the point Z is here, then also this angle will be alpha. If Z is somewhere here, then also this angle will be alpha. Why it is so? Because standing on the same chord, the angles made at different positions on the circumference of the circle, the angle remains same. This is the basic theorem of circle. So in this case, the locus of Z is nothing but on the circumference of this circular arc, where Z1, Z2, the line joining Z1, Z2 is simply a chord of that circle. Is it clear? Now, if alpha is pi by 2 or minus pi by 2, whichever, if we take clockwise or anti-clockwise direction, whichever we take, in that case, your Z1, Z2, the line joining Z1 and Z2 will be the diameter of that circle. Is it clear? Because then we know that the angle in a semicircle is always a right angle. So your Z1, Z2, the line joining Z1 and Z2 will be the diameter of that circle. Otherwise, if nothing has been said for alpha, we will say that the locus of Z is lying on this circular arc. Is it clear to all of you? Absolutely. So that's all about this video. In the next video, we are going to discuss about the conic section on an Argand plane of parabola, ellipse and hyperbola. Right? So till then, goodbye and take care.